Hey, my name is Nihir from featherai.com. Check us out if you want a free way to share, deploy, and monetize your machine learning models. This week, I have 5 advances for you in AI. First of which is BlenderBot 2.0, released by Facebook AI Research. Now, in case you didn't know, the first BlenderBot was a very performant chatbot. BlenderBot 2 improves on this by building a long-term memory of your search conversation, your search history with the model, and it can actually search the internet as well, meaning that it can actually update its internal memory and information base based on new information which comes in via the internet. This wasn't possible with previous chatbots such as the original BlenderBot or big language models such as GPT-3 because their internal memory is fixed based on the training data that the model was trained on. Now, in experiments, this model produces improvements over the previous state of the art, namely BlenderBot 1.0, in terms of engagement with a human and in terms of human-like conversation as well. The authors are concerned about the safety of the model, and to this end, they fully open source the model, including the dataset and the implementation. Links are below, you can check it out and play with it if you want. The next advancement is also by Facebook AI Research. Now, they've introduced a new model which beats state-of-the-art in image classification, trained on very low resources. So they call this model the ConVit, or Convolutional Vision Transformer, and it's a fusion between the Vision Transformer and the CNN, taking the best inductive biases from both architectures. In the case of the CNN, namely the 2D grid which slides over the image, they induce this inductive bias via a novel gated position self-attention algorithm. You can check the paper out, link is below, and it will give you more information about how this works. Now, they perform many ablations to demonstrate the effectiveness of GPSA, including its sensitivity to hyperparameters, and also they take a deep dive into the layers of the transformer model to see exactly what GPSA is attending to in each image that's been fed in. Thirdly, we now have another open source version of GPT-3. Now, I imagine if you're watching this, you know what GPT-3 is, and that, well, access to OpenAI's GPT-3 has not been so open. So this particular version was released by Eleuther AI, which is a grassroots initiative to open source AI research. This was a 6 billion parameter model trained on a dataset called Pile. Now, Pile is an open source dataset which is built for extremely large language models. It's 800 gigs in size, and it contains about 22 or 23 high quality datasets, some of which are new for the Pile dataset, some of which are have existed in the research world for a while. Just for comparison, the largest GPT-3 model by OpenAI is 175 billion parameters. So while this model isn't quite to that magnitude yet, on the equivalent 6 billion parameter model that OpenAI released for GPT-3, Eleuther AI reports similar accuracy and perplexity scores. However, they do warn of a bit of data contamination in the test set. Still, they have the open source code and a web demo. Links are below, so go check them out. Now, this is possibly the coolest thing I have for you this week. Speech Neuro Prosthesis has real-world applications and is an amalgamation of over a decade's worth of work by UCSF neurosurgeon Edward Tang. UCFS is the University of San Francisco, and what they've done is developed an algorithm that can translate brain signals into text on the screen. So literally, they'll stick a sensor on the top of your head, and just by thought, you can actually communicate or you can actually synthesize text. Now, this was successfully applied to a man who has severe paralysis and was unable to communicate naturally. So as I said, I love to see this practical application of AI. Currently, the vocabulary is limited to 50 words and uses neural networks and the Moses language models to perform the synthesization and also the autocorrect of the text on speech. Finally, diffusion models. Now, diffusion models have been around for about half a decade or something. They're inspired by thermodynamics. However, more recently, they've been picking up in hype. So alongside GANs, VAEs, flows, and autoregressive models, diffusion models is another form of a generative model. Now, recent work just being released this year has demonstrated their prowess in image synthesis, matching state-of-the-art GAN results. Typically with generative models, you have a trade-off between tractability and flexibility. Diffusion models are advantageous in the fact that they come with the advantages of both. However, they do have a lengthy sample and generation time. The math is a little deep, but if you want to learn more and you're interested in generative modeling, check out Lillian Wang's awesome blog post. Link below. That's it from me. Hope you have a fantastic day. And once again, check us out at featherai.com if you want a free way to share, deploy, and monetize your machine learning models.